In this video, we are going to change a standard form quadratic equation to vertex form using completing the square. And you previously were taught how to use completing the square to solve quadratic equations. This is going to be slightly different in that instead of having a 0 over here on this side, what you're going to have is a y. And that's going to make things a little bit different because you're going to have to keep the y there throughout the entire process. Okay, so let's take a closer look at this. Another problem it's going to cause is this 18 out here. Now there are two things I could do with it. I can move it over to the side with y and then at the end move it back. A lot of people prefer that. Or another way to do it is just kind of stick it off on the side like this, and then when I go to complete the square, I kind of forget about it and complete the square on only the other part of the right hand side. So let's see how that works. Okay, so here is a equation with y that I want to change into vertex form. So what I'm going to do on this one is I'm going to put the 18 out off to the side a little bit and just kind of forget about it. And on the rest of it, what I'm going to do is look for some value that I can add to both sides that is going to create a perfect square. So I'm going to add some value, let's call it c. Inside the parentheses, it's going to create a perfect square. So if I add c to the one side, I have to add it to the other. And so to figure out what's going to make a perfect square, I take half the center term, that would be 6, and then I square it. So c would be equal to 36. So I have to add 36 to both sides. And now then I'm going to rewrite the part that's in parentheses as a perfect square. So x squared plus 12x plus 6 is going to be the perfect square of whatever half the 12 is. So that would be x plus 6 squared plus 18. And now all I have to do to create a equation in vertex form is to move the 36 over to the other side. So I'll subtract 36 from both sides. And I'll have y is equal to x plus 6 squared minus 18. And that's vertex form, and my vertex would be at, the opposite of the sign on the x would be negative 6 and negative 18 for y. Okay, let's do that again, but this time I will move the number over so you can see how that works. It may be a little easier for you. So I have y is equal to x squared minus 22x plus 16. And now instead of moving the 16 off to the right, I'm going to subtract 16 from both sides. And I'm going to get y minus 16 is equal to x squared minus 22x. And now I'm going to have to add something to both sides that's going to make it a perfect square. So you could look over here and say that, okay, half of a negative 22x, that's going to be a negative 11. Square negative 11, I get 121. So I'm going to add 121 to both sides. I've got to add it over here. And so what we have is a negative 16 plus 121. On this side, I will have y plus 105. On the other side, I'm going to write it as a perfect square. And then my last step is just to move the 105 back across. So I'll subtract 105 from both sides. I get y is equal to x minus 11 squared minus 105. So the only thing different about what I did here is instead of having the number stuck out to the side on the right hand side, I put it on the left side, and then of course when I added the c to it, it gave me a number 105 in this case, and I moved it back across. So that may be cleaner for you to do if that's what you like. The vertex on this one would be 11 minus 105.